Hello everyone, this is the lecture/demo of using the ARP protocol. So we'll start with what is ARP, stands for Address Resolution Protocol, and why do we need ARP and how ARP works. So we've looked at this before quite a few times, but as always the user is up here at the top where the TCP/IP and then the data goes down the stack, or the user process is up here, and the data goes down the stack onto the physical wire, and then to the other end, and then it goes up the stack from the wire to the user. So we're going to look at ARP, and ARP operates at the IP layer, so down here. So it's not something that we use with applications. This is an internet support protocol, just like ICMP. ARP and ICMP support the use of the network. So ARP is a transparent protocol. You don't really know it's going on, or the user doesn't really know what's going on. But if it's not working, networks would be disabled without it because it has a supporting role in the physical transmission of packets. So it's done by each node, and each node keeps its own ARP tables, and they're created by discovery. So there are no services involved. This is all on a node-to-node basis. So what it does is it matches the IP address to the MAC address. So in order to transmit a frame on the wire, that is done by MAC address. That's the wire itself, what's on the physical wire or through the Ethernet, through the Wi-Fi, we have to have a MAC address to know who it's coming from and where it's going to. So at that level, at the physical level, we need the MAC address. So if we don't have the MAC address, we can't actually send a packet, so none of the other stuff will work. So each node will keep its own ARP tables, and it's the ARP tables, because they have a MAC address and you can only physically send to someone who's on the same LAN as you. We only keep the MAC address information, or the ARP information, for the nodes that are physically connected to the same network. So all of your subnet. ARP is described in RFC 862 and the updates to it, and if you look at it, it's quite an old protocol. 862, that's quite old, and you can have a look, of course, if you want. I'm not going to do it in this lecture. You can watch the slides here and click on this link. In IP version 6, this is done with something called Neighbor Discovery Protocol, but this is, again, most of what I'm doing has to do with IP version 4, just because it's much simpler for you to explain. And once you understand IP version 4, you can understand IP version 6 eventually. So we go back to the NIC. Each of our nodes, in order to communicate on a network, must have a NIC. So that's either a NIC with a physical interface that we plug in or an antenna. And each NIC has a unique 48-bit MAC address. I talked about this before briefly. So it's unique, and it's assigned by the manufacturer. Another name for this is the physical address. So it's a bit like, well, this one is more like the actual serial number of your house rather than anything else, because it's physical. So it's stored inside the firmware. So this is burnt onto the firmware, and of course it can be spoofed just like IP addresses, but it's stored in the firmware, and in the chip on the NIC, and it has the driver software and other software necessary for the NIC to communicate with the operating system. So in order to get a frame to and from a node, we need the MAC address. And unlike an IP address, it cannot change. So if I go to a different network, my IP address will change, but my MAC address will always stay with me. It'll always be the same. So the MAC address is a bit like your social insurance number, and your IP address is like your postal address. I think I've mentioned this before. So the postal address, well, when I move to a new house or a new apartment, or if I'm staying with my friend for a few weeks, my address changes. But my social insurance number never changes. So both the MAC address and the IP are put in the header, but they're used for different things. So each organization, so as I said, this is burnt into the NIC, and each organization will have to burn it into the NIC, and their organizations are designated OIUs, so that you can tell, so organizational units, and you can tell which company created your NIC by looking it up. So let's take a quick look. So we'll look at on my VM here. And here I see the MAC address. Of course, the loopback, it doesn't really have a, it's a kind of a fake thing. It refers to me. It doesn't have a MAC address. But my my virtual NIC does, and this is the MAC address. So I'm going to copy this. I just copied it. And I'm going to plug it in on that website. We're going to use this website. We'll plug it in and find the results. So the results are that and this is the organizational unit. So that was assigned to VMware, which makes sense because this is a VM running on vSphere server. So if you were to do this with the NIC of your desktop or your laptop, it'll tell you who owns it. So who owns it, who created it. So those blocks are unique and assigned to a particular organization, but then the rest of it is also becomes unique. So a MAC address can't be duplicated. If you have a duplicate MAC address, you have a similar problem to an IP address. It's going to mess up your network. So again, I believe I've said this before, but a MAC address is analogous to a social insurance number. It's always with you. It will never change unless you get your identity stolen. So it never changes. But an IP address is like a postal address. So if you move houses, that will change. But the MAC address is how you physically communicate with your computer. So this is why we need ARP, because we need ARP to match those two together. So if I go to Starbucks, my MAC address will be the same, but my IP address will change to the Starbucks network. If I'm at home, my MAC address is the same. My IP address is from my home network. So packets at the link layer have to be physically connected to the same LAN. So this is why we need the default gateway. Remember, I've spoken about the default gateway. The default gateway is physically on our LAN. So the first hop or the first route on our route to anywhere is always our default gateway, which is on our LAN. So we will send packets to that, and then it will take care of the MAC for the next layer. So frames are sent using the MAC address. That's how they communicate with each other. They have to know the MAC address of each other. So the way that the sender, so if I'm new on a LAN, let's say I just get to Starbucks, then I don't know the MAC address of anything. So what I have to do is I have to use ARP, which will be used for me pretty much, to discover MAC addresses. So using ARP is triggered by any of our requests off network. So how do we ARP? Well, how do we use ARP? So ARP is a command and also the name of the protocol. So it's a request response conversation between hosts on the same physical LAN, so with no intervening routers. And so if I'm new on a LAN, then what happens is an ARP discovery, let's say I want to ping something, then an ARP discovery will be sent. So the ARP discovery is a special ARP packet that broadcasts to this MAC destination. So you notice FFFFF for MAC address, that's all the bits are on. So it gives, the packet has that FFF and it has the IP address that it's looking for. So the machine that matches the IP address responds with its own MAC address. And then that will be put in the ARP table, the ARP cache for my computer. So if I get a response, then I will save the MAC address, the IP address, and a time to live in my ARP cache. So let's have a look at our ARP table using the ARP command. So if I type ARP, -n will say don't look up host names. I don't have any host names. So what it does is it tells me the IP address, the hardware type, so it's a virtual Ethernet, and this is the hardware address, some flags, and the interface that it's on. Notice IP address show. Here we see the interface name. So if I have multiple interfaces, it will tell me which one that it's associated with. So what I'm going to do is I'm going to ping another host on the system. If I ping, this is my default gateway. Well, let's use the IP command. So this gives me my default gateway. So my default gateway is 10.172.0.1, and of course I have the IP address of that because I've used it for a lot of things. So if I ping that, there's no need to add to my ARP table. But let's ping another computer on the same network. Let's try 10, 172, 1444. So I just pinged that. So what happened is, in order to send that ping packet physically on the wire, what I have to do is find the MAC address for 10, 172, 1444. So just like a DNS lookup, all of this happens kind of automagically. So now if I look at my ARP table, let's clear this. Oop. Now I have the hardware address of the other host. So what it's telling me is that, okay, if I want to send a packet to this host, I have to use this address. So it added it to my ARP table. So these will eventually expire and have to be reused. But every time I need to talk to a different host on the same network, I need to have the hardware address of it. So everything, mostly, like if I do this, so ping. Oh, no, it's not pinging, but it's not responding to the ping. But ping McGill. So it's responding to the ping, but I didn't need to get anything new in my ARP table because this, since it's not on my local network, has to go through my routing table. And I can tell, so it has to go through my default route. So as you can see, the first thing that it does is goes through my default gateway. So I only need the default gateway for things that are off, and everything else that's local, I'm going to need to have the hardware or the MAC address. The hardware address, physical address, MAC address, they're all the same thing. So we can do the same thing on Windows. So I'm using ARP-A or -N. So it's slightly, again, it's implemented slightly differently. And as we can see, this 1049 is for my VPN. This 0 is my physical IP address. And notice these are the MAC addresses of things that are on my local network. So 192.168.0.1, that's my default route. 0.15, that's another box. 0.19, and these two are broadcast addresses. So everything that has any physical communication needs to use the ARP protocol. So ARP and ICMP are kind of supporting protocols. So this is what happens. So Fozzie's box wants to send a datagram to Gonzo. So maybe ping, it could be I want to SSH to that box, it could be anything. It doesn't really matter. ARP has to come first. So it doesn't know anything about Gonzo's box, so it sends a broadcast, an ARP query packet, containing Gonzo's IP address, so it's already done the DNS lookup, and the destination MAC address of all ones. And then Gonzo recognizes its own IP. So everybody on the network receives it, but Gonzo recognizes its own IP and then responds with its own MAC address. So all of this, there's no server involved. This is all in part of the TCP/IP stack. It's all done for us as part of the TCP/IP stack. It says, okay, this is my IP address that you're looking for. So it replies to Fozzie with its own MAC address. And then what happens is Fozzie will cache or save the IP to MAC address pair with some timeout information. And then it will use it to actually send packets to Gonzo. So the MAC address will be used for the physical distribution of the packets. And without this, none of the other protocols are going to work. So ARP is necessary to support the physical sending of packets, and that's always the first step. It maps IP address to MAC address, and the information is kept on a per node basis. So there's no central services that does this. Your TCP/IP stack will keep these tables for you. So that's it for ARP. Thank you for listening.